A perfect square. Example would be 2 to the second power. That is a perfect square because you can multiply that number twice. 4 is a perfect square. You could also use another number like 3. 3 to the second power really just means to multiply it by itself. 9 is another perfect square. Before you move on too much, I'm going to give you a visual, then you'll get to explore this on the grid paper. If I have a square like this, and I say this side is 5 units, and this side is 5 units. They're the same. That's a perfect little square. Look at that square. He is perfect. What would be the perfect square results if you multiply those two? Milo. 25 is another perfect square. You can find perfect squares by using exponents like we did up here. 2 squared is a perfect square of 4. You could do 3 squared, you could do 5 squared. There are about 20 perfect squares that you need to have memorized for next year. You guys will get that list starting tomorrow. For the most part, if you don't have them memorized, you can still find it out. It's just going to go a lot quicker for you if you have the memory in the bank. You could do 20 times 20 and have that memorized, but you don't need it right now. Example 1, we already did it. 1 squared is just 1 times 1. Did we do 1s? No, we did 2s. 1 times 1 is a perfect square of 1. 4 squared is a perfect square. It's 16. 16 is a perfect square. Big idea. 1 and 16 are perfect squares because you can multiply them by a whole number twice. I just gave you about 3 of them. You're going to try to finish this chart with other perfect squares, and you're going to prove it to me on a grid paper. If I know that 1 is a perfect square, my dimensions are 1 times 1, and so my perfect square that I say is 1. That would work. I proved it by saying 1 times 1. Another perfect square could be 4. 2 times 2 is 4. What's another perfect square that I already found out? Frankie? Yeah, we already, or you can give me, I think we did 3 times 3, so the perfect square would be 9. If you want to write the squared, and that kind of helps you, you can put 3 squared here, or 2 squared here. On your grid paper, this is what you're going to show me. I just did 1 times 1, and so I'm going to put 1 box by 1 box. This is a perfect square that's 1. That's my first example. I used 1 by 1. I could then prove another one by doing 2 by 2. This is a perfect square of 4. You could keep going with 3 by 3. That is a perfect square of 9. 9, 4, and 1 are all perfect squares. Shade in the perfect square or identify it and then fill out the box right now. I'll give you about 2 minutes to work with your partner and compare. See how large of number you can get with the perfect squares. I did 1, 2, then 3. The next step you might try is 4. What is the perfect square with side lengths of 4? One, two, three, four. 1, 2, 3, 4. 4 by 4. What's the highest number that you got to? That's 7 by 7. All right, give me another perfect square besides 4, 9, 16, or 1. If you found a perfect square that works, raise your hand. Give me like that, or just one. Liliana?
8 times 8.
Sure. 64 would work. 8 squared is 64. What's another one? Jacob?
36.
Yeah. 6 squared, or 6 times 6 is 36. That's 1, 2, 3, 4, 6, 8 squared. Anyone have anything higher than 8 squared equaling 64? What'd you get, Kierland?
81.
Yeah, 9 squared is 81. Sure. Mackenzie? Yeah. You could keep going up until like the largest number you could think of, multiply it by itself, and that would be a perfect square. Like I said, these are the essential like 10 that you need to know. 1, 2, 3, 4, I'll add 5 in here too. 25 is a perfect square. But once you get past 10, they get a little bit trickier, and we'll work on memorizing those in 8th grade with whatever teacher you have. That's the perfect square table. Oh, I did throw that in there today. Skip the table for now. We'll throw it into the next one. Okay, so perfect squares are taking the same number, multiplying it by itself 2 times. The square root is the opposite of that. If you're finding the square root, it is the inverse of a perfect square. So square roots versus perfect squares are inverses. What are some other opposites that like you learn in kindergarten? Possibly. Like I'm thinking addition and subtraction. That's an inverse. Carolyn? I am, thanks. Addition versus subtraction would work. What's another inverse? You learn it in like 3rd grade. Yeah, multiplying and dividing is another one. So the inverse of square roots are perfect squares. If you know what a perfect square is, you can find the square root. Multiplication and division versus division. The inverse of squaring is taking the square root of a number. The inverse of finding 2 squared is finding the square root of 4. The inverse of finding 2 to the second is finding the square root of 4. Why does mine look weird? You don't have an example for that one. That's okay. Okay, let's just put the square root of 4 since we just did that one. So if you're asked to find the square root of 4, I'm thinking in my head, what times what is 4? Well, 2 times 2 is 4, so the square root of 4 is 2. The question you're asking yourself is, what times itself is equal to 4? And that answer is 2. 2 times 2 is 4. The square root of 4 is 2. Find the square root of 16. Silent hand if you know what that would be. What times itself is 16? Alexis? 4 times 4 is 16. The square root of 16 is 4. Next page. You have a few other numbers. What is the square root of 169? What times itself is 169? What's the square root of 16? What times itself is 16? Then you're going to do 8 squared, then 11 squared. 8 times 8 is what? 11 times 11 is what? And go ahead and work with the partner for 3 minutes.
Wait, are we doing it like the square roots? So is number 3 like is the answer 64? Or
Yeah, it's 64. Yeah, so if it's the square root, you're doing what times what is 169. If it's squared, you do 8 times 8. These are two different problems. This is the square, this is the square root. Square, square root. What times what equals 160? What times what equals 16? What times what is 16? 8 times 8. Cool. That'll work. Cool. 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 Alright, if you're done with number 1, raise your hand. What would the root of 169 be, Mackenzie? Nice. Would you get to larger numbers? It's a little harder to do mentally, and the best way to go about it is guessing and checking. I know that 10 times 10 is 100, so it's got to be bigger than that. I could guess and check with 12, and I'm going to see that I have it close, but not quite there. I'm going to try 13 next, and I would get the right answer. So my answer for the root of 169 is just 13. What's the square root of 16? Easier mental math, full class. 4 times 4 is 16. That works. Do you need a packet? Okay, cool. Then you take a perfect square. 8 squared is 64. 11 squared would be 121. You might need to do some math for that on the side. Label the following on a number line. Let's start at 0 and go up. What is the smallest number that they give us here? 3 would be the square root of 9, so I'm going to put that on the number line right here, above 3. What's the next smallest number, Oshu? 2 what? 2 to the second, which would go above 4. 2 squared is 4. What's the next smallest number?
5.
Frankie? The number 5 is the root 25. And the biggest number that's going to be way over here is the last one. 4 squared is 16. Cool, cool, cool. And I don't have that page, so let me show you. You got 10 minutes. You're going to work on just the